Welcome to yet another Stewart Squared episode. And we are going to be talking about China, I think, because I went and I did a special AI Whispers high signal post, which I do every Sunday. And if anybody's interested in getting those updates, please send me an email. But I'm going to throw a few crazy stats at you and have you react. So compute asymmetry. The US owns 75% of global AI compute, whereas China owns 15%. The Chinese figured out how to, They figured out how to achieve the 7-nanometer without EUV. So without ASML's crazy $150 million machine, they figured out how to create a 7-nanometer semiconductor chip with deep UV plus quadruple lithography. They are doing some crazy robotic stuff. They're open sourcing absolutely everything except for the process of how they build these nanometer chips and also specific robotics things. So they're going to try to dominate the building robots that build robots. And then they'll sell those robots to other people, but they won't sell the robots that build other robots like ASML with that machine. And so that's all part of their strategy to basically dominate manufacturing. Any reaction there?
7-nanometer is pretty old.
Yeah.
The current standard is 2-nanometer, which Apple's doing through TSMC.
Wait.
TSMC has mastered 2-nanometer, 3, 4, 5, etc. But you have to get the chips to be smaller and smaller, pack more into a smaller and smaller space. And right now, 2-nanometer is the leading edge. So it's expensive and you have to pay for it. And Apple has a really bonded relationship with TSMC. So their M5 chip and the A5, I can't remember, they're in Powerall, are 2-nanometer process. There are others that have achieved that. The size isn't as important with GPUs, which are used for training AI models and other tasks. It's just really a matter of the central processing unit, not the graphics processing unit or others. And so you have to kind of tease out all the different pieces of this.
Yeah.
But if they're capable of doing 7-nanometer, they're pretty far behind.
Yeah.
Right.
So,
and maybe that's relevant to GPUs, to training AI, but that's a separate issue from building devices that have a central processing unit.
Man, okay. So first question came to mind, how does Apple and TSMC, how does that relationship work together at the business level? But what you just said about GPUs and CPUs and it's so crazy because you've seen it all from the very beginning of a CPU, right? Like in 1980, what did a CPU do?
Well, the Apple II was introduced in 1979, and it used see how good my memory is here, but 6502, a Motorola 6502, which was an 8-bit processor. They hadn't even gotten to the point of process for manufacturing the chips. These are low-volume chips that Motorola and Intel were competing in this new area of devices, which is like hard to remember how slow and incapable they were relative to what we have now. So over the past 45 years, longer really, since 75, so 50 years, the semiconductor industry has pulled off this miracle, which is referred to as Hewlett's Law? No.
Moore's Law.
Moore's Law, where they doubled the speed and capacity of processors every 18 months. And that happened, right? There's actually a slowdown in that. Right now, that advancement, because they're reaching the sort of physical limits of how small you can make it. So there's a whole secondary set of things that they're trying to do, one of which is stacking the chips. Right? So instead of just one level of chip, they have multiple levels, and they're communicating both sideways and
and
there's like This is all ones and zeros running around inside these processors. Um, so right now we're in a world where you have to really have a lot of money and a lot of focus to be operating with 2-nanometer process. So Apple and TSMC have a really close relationship because Apple has depended on TSMC to make this stuff rather than Motorola or Intel 50 years ago.
Hmm.
And in the semiconductor business, the making of the thing and the designing of the thing is split. So Motorola and Intel still design chips, and TI and a bunch of others. But TSMC is really the only, let's see, South Korea. It's the big manufacturers. Samsung
Hmm.
is capable of doing this, but they're behind TSMC. But they're still investing in it and making it happen. So China is paying attention, certainly. And their primary manufacturer is SMIC, Semiconductor Manufacturing of China, in China, SMIC, which is a big company, but a fraction of TSMC and way behind TSMC in the process. So there's only so much they can do, right? Because they have to have the people in the country that know how to do this stuff. And so far, TSMC has absorbed all that, and it hasn't gotten to China.
Oh,
So,
interesting.
Apple in China has developed the supply chain and manufacturing capabilities to be able to scale manufacturing of devices, whatever they are, whether they're earpods or watches or whatever, um, with state-of-the-art components. But the core components still come from Taiwan, um, which is why everybody's like freaked out about China and Taiwan. Um, so when you get down to the process of manufacturing at least CPUs and probably most semiconductors, China still is pretty far behind.
Yeah, brilliant. That gave me a lot of insight. It's funny. I left out part of my notes, which was, they achieved the 7-nanometer without EUV using multi-patterning. Who did that? SMIC, which I didn't know before. That is the company in China. And what you said was really important there. No knowledge transfer between, well, I'm sure there's some knowledge transfer between TSMC and SMIC.
Well, the thing is, there was this book out there called Apple in China.
Yeah.
Apple aggressively transferred manufacturing know-how to China, and they optimized for that
Oh,
and applied it everywhere else. That's a different kind of manufacturing than making the chips themselves. And
that happens in
uh,
Taiwan. Making the chips happens in
that
Taiwan. We're
is
trying to bring it
TSMC.
back.
Yeah, and TSMC is building a plant in Arizona. They're beginning to build, I think, 5-nanometer chips there, which are
Oh,
used for low cost other kinds of applications, not the leading edge. Um, and that they're way behind schedule and way over
yeah,
budget
yeah,
building that factory, but they are
yeah.
building the factory and they're putting the money in to do that because it's in their interest to have an alternative to their plants in Taiwan because it takes a
Whoa.
lot of the pressure off.
Because they've got a
They
huge
can,
amount of political pressure right now because of Trump, the bull
oh
in
yeah,
the bull in the China shop. So I've just learned so much about China this morning, including about their economy and how it's not as golden as a lot of people think. There's a lot of issues with the Chinese economy right now.
now
Most,
Russia's like teetering on the
yeah,
edge.
yeah,
Their oil and gas revenue is going down, and they're spending all this money on the war. And so there's a perception that Putin is trying to get the war done before they run out of money, and it's right on the
yeah.
edge. China is in a
Interesting.
different situation because uh, basically they encouraged the explosion in real estate
Yeah,
uh,
exactly.
and way
Yep,
overbuilt. And
yep.
the banks that made those loans are in trouble, and they're being supported by the central government. But so and plus there's a very significant issue of labor because they had the one-child policy for so long. They never produced enough babies to replace. So both China and India are at 1.4 billion, but India's still growing because they're still making babies, and China's is going down. So it'll take a few.
But the robots are coming, and that's what I was talking about. Is that China has a brilliant strategy when it comes to semiconductors, open source. They're open sourcing all of their AI models to put incredible pressure on the foundational labs who are all trying to make a profit. So that's why they're all closed source, is so that they can make a profit,
Not all
reinvest
it. Yeah. Meta.
But I mean, Meta's not even a player at this moment, which is the craziest part. So they're building robots that build robots, and it feels like they're going to quickly be able to handle that issue that you just said, and also handle it for all the other countries going through demographic crisis. Do you agree? Disagree?
So when you say robots making robots and robots doing the work, this latter part, there's a big range, right?
Yeah.
Everybody thinks so. There's a humanoid robot like sitting on a factory line. Most of the robots used in manufacturing are not humanoid.
Yeah.
Single arm, or they're just special purpose or whatever. And they are very good at that. And they are sort of globally producing more robots than anybody else. The majority of production is in China. So you're putting up something, huh? Okay.
Yeah. So
the humanoid thing is a separate thing, which they're also investing in. And there's like 2 or 3 companies in China that are making humanoid robots that appear to be ahead of Tesla/X, as well as Figure and Boston Dynamics. And there's a set of domestic American manufacturers of robots. It's kind of at parity there, but because China's so good at scaling, there's a concern that China will scale faster than we can.
Yeah. And I think that's true.
Just
and
like
so
they've done with electric vehicles. Yeah.
Then the electric vehicles is the other thing we can talk about. But I'm just pulling up all of the different things that are related to what you're talking about. First, the things that they are not open sourcing, the things they are keeping tightly under wraps, is the servo motor with harmonic drive reducer. So that's one of them, and we can do whatever it's doing here, which I don't know what it's doing, but it seems robotic. And then we've got the humanoid robot, the Tiangong robot is the humanoid robot that you're talking about. And we got the Fourier.
The leading company there is Unitree, which is...
And that's this one here.
Look at the third, yeah.
Yeah. Do you know what Fourier N1 BOM? What is BOM in assembly manuals?
Bill of materials is usually what BOM stands for.
Bill of materials. Interesting.
Yeah, it's like the cost of buying all the stuff that you put into something. Bill of materials is all the materials that you use to manufacture something.
So, but they're going to I agree that it's not the humanoid. The humanoid is sort of like a red herring, and that brings to mind the company called Figure, which is in the United States, which seems like a total Ponzi scheme.
Which I mentioned, right? It's in there with Tesla and Boston Dynamics, but they're currently valued very highly.
Yeah.
Before they've actually started producing anything.
And that's the crazy part, is that it seems like, as we were talking about before we started recording, that like a lot of the US stuff is a hall of mirrors, where like Figure is worth billions of dollars. They haven't made anything. All the quantum labs are worth billions of dollars. They haven't made anything. So there's just a whole bunch of money going around all these things, but yet it feels like we've talked about this many times and we can't come to conclusions because it's so difficult to understand. The US government just basically prints money, and it has a lot of money, and it's the dollar reserve. And this is really important, but in some ways it's not that important. And it kind of removes our ability to make things, which China dominates and continues to dominate.
Right. So this is the whole issue about tariffs versus subsidies. China subsidizes heavily. And in China, the thing that a lot of people miss, although the reporters know it, but they don't make a big deal of it. In China, there's this Chinese Central Communist Party, it's CP. The subsidies of manufacturing are actually done locally. So Shanghai, Beijing, Guangzhou, whatever. And the mayors in the ecosystem in China are incredibly powerful. So, in fact, the Central Communist Party has to be careful about not stepping on their toes because they control the labor and a lot of the money. And so, if they decide, and I just read an article about, I think it was Guangzhou, but where they decided they would become particularly good at different things, and they become so good, there's so many companies started that they're killing each other on
Yeah.
pricing.
Yeah.
So Xi Jinping has actually made a speech about encouraging them not to do this because it's creating churn in the economy and it's not helping the overall labor economy. So, I mean, it's a really complicated system in China.
Yeah.
And it's easy for Americans to go, well, okay, they're communists, but it's still like us.
Yeah.
Not really. It's not something we can reproduce or compete with. And they've been doing it for 20 years since Xi Jinping started. And you got to give credit to Xi Jinping for being a pretty smart dictator because he's like figured out how to get control over everything and at the same time launched all this strategic stuff, which has really paid off. Maybe personally him, maybe not, but some collective. So there's a perception right now that China's on a roll, and it's going to continue to be on a roll because it has been on a roll. And of course, so people always take what has happened and roll forward.
Yeah.
But there is weakness in the Chinese economy that could get in the way of their and particularly the amount of money they're spending on military expansion. So it is really complicated, right? It's a many different things at once, and China and Russia don't really get along, but they're pretending to get along right now because the common enemy is the U.S. and India. China's in there, and the U.S. is in there. Currently, Trump's pissing off India. Well, he's pissing off everybody. So except maybe Bibi. So, the geopolitics is really complicated, and there are many different things going on, and usually anybody who tries to predict what's going to happen is wrong. So I always have the contrarian notion that if everybody agrees on something, it's probably wrong.
Yeah. So, and
right now, everybody agrees that China's the threat, right?
Which means they're wrong. Yeah. No,
we don't know why or how, but
So, and that feels like unanswerable. It's about the future. The robots might come in time to save the Chinese from the demographic prices. It might save everyone else too. It's all this complexity, and now we got transformative tech, which is entering a layer of chaos into the already chaotic situation, which has been previous waves. And this is what the show about. And I want to talk to you about the GPU and the CPU because I want to go back to what we were talking about earlier about the GPU. What is the main difference between a GPU? You have graphics, you have central processing unit, graphic processing unit, but the fact that everybody's investing in these GPUs, doesn't that shift everything from the CPU? Doesn't the CPU, particularly with LLMs, becoming such a different model?
No. I have to be careful of it. In a computer, in a generic device, computer like we're looking at, or smartphones, you need a central processing unit because a central processing unit handles all, I would say, instructions and any kind of instruction, either to move stuff between memory and the processor, or move it into the screen or whatever. GPUs were developed to specialize in putting pixels on screen.
Yeah.
So it was a limited set of instructions
and
very focused on one thing. It just so happened, this is how Nvidia got where it is, that they started making processors for game machines to put pixels on the screen as fast as possible to create realistic, fast interaction with games. And GPUs got associated with games because it was graphics processing unit. They were processing graphics instructions as fast as they could. So it was designed as a second chip. It worked with a CPU, but was specialized in putting stuff on the screen. It particularly became more and more important as screens got more dense and had more pixels on them and so on and so forth. So CPUs still have a big role to play in general purpose computing devices, smartphones, and computers, even servers. So the key architecture in CPUs, what created a problem for both Motorola and Intel is the ARM architecture. And ARM started as a company in England called Advanced Research Machines, but they designed a architecture for GPUs which could be applied to different issues, right? So the ARM architecture is at the core of Apple's um, system. Google's also adopted it. I can't remember what the process they call them, tensor. Anyway, so they actually
TPU.
now have
TPU, tensor processing
TPU,
unit.
yeah, the tensor processing unit, and then Amazon also developed its own ARM architecture-based processors for servers, right? So beneath the kind of Amazon Web Services thing, they actually started building servers that were really high performance, and that was part of how they protected their uh, interest in Amazon Web Services and why Google was kind of behind and Microsoft was kind of behind. But it's why Amazon Web Services is number one in cloud services now. So you always have these generations of things going on. And it just happened, and I don't think there was any forethought in it, that the instruction set used for GPUs turned out to be really useful for training models. And that's because when you train a model, you take this massive amount of data, and it's really not structured data, and you have to process it really fast. Well, that's very similar to processing pixels on a screen architecturally or design-wise. So Nvidia, paying attention, right, started modifying their architecture and their chips for AI back early on, right, with Google. And so they were in there at a level that no one could catch up to. So there is really no alternative to Nvidia, which is why it's worth more than $4 trillion now, because it's not really related to their revenue. It's the fact that they are in this protected moat in the foundational AI model. And the only thing that could be a problem for NVIDIA is if they kind of train all the foundational models and then we don't need to do it anymore. But they are very smart, and they're also introducing chips that are, more relevant to the other parts of AI,
What are the
whether
other
it's
parts?
running like neural networks,
Uh,
doing real-time
yeah, yeah. Yep.
modifications to your foundational models. I mean, there's a kind of this blended model that we'll end up with where foundational models are at the bottom, but there's a bunch of other stuff on top of them. And NVIDIA knows that and is trying its damnedest to make sure nobody else gets in there. Now, there are a few startup companies, but this is why Intel is such a disaster, because they were they were making GPUs for computers, personal computers, IBM, et cetera. And they couldn't figure out the mobile thing. They just kind of missed the boat on mobile. They tried to use their CPUs for mobile, and that didn't work. And then they missed the AI thing. They just missed everything. They've missed everything since the CPU.
And we haven't talked about the history of Intel. Let's talk about the history of Intel, because in the 1980s, what was your impression of Intel in this whole evolving Game of
Intel
Thrones?
was, there was this thing called Wintel, Windows and Intel.
Oh, interesting.
So Microsoft and Intel ruled the personal computer, right? And there's a separate thing that happens with Apple that's not synced with that, because Apple went through major architectural transitions in both the Mac and the iPhone when it showed up. But Intel couldn't get out of its own way to do something new. They kept using their way of thinking with CPUs for more specialized chips. So they missed GPUs, they missed, everything. And so when you look at Intel now, it's really hard to see what they have that can be useful going forward. So back in the day, they were incredibly powerful, but that frequently leads to misjudgment and strategy and so forth. So,
1980s. What was your first impression of Intel? Do you remember when you first heard about Intel?
you have to go back. They were started in the 70s. They started with memory chips, putting data in memory.
Wait, what is a memory chip? What is a memory chip? What does it do?
Well, you have 4 terabytes of memory in your phone. That's static memory. SRAM, I'm kind of lost now. I don't
Yeah,
really
don't worry
remember all
about
the
those.
distinctions, but basically it's just where you store data while you're not using it. That's memory.
Got it.
And that's opposed to hard disks. In the old days, you had about both hard disks and memory because memory was so expensive relative to hard disks in terms of storing stuff. So you'd
Oh.
store stuff in RAM, memory, random access memory, in silicon that you knew you were going to need, and then you push everything else to this hard disk. It's an architecture, right? You have to like design your CPU and your hard disk and your memory to all work in concert. That was Intel's strong suit. That's what they
Oh.
dominated. But with graphics processing units, which still have a CPU but are important when your applications require high-speed graphics. But the thing I can't figure out is all these NVIDIA chips are sitting there, huge numbers of them packed into these servers. Is there a CPU?
Hmm.
I don't know. I don't know. How do they manage that? How do they manage all the interaction between all the
I,
different
I
chips?
I want to write that down as a question, but I don't know how to ask it. Does NVIDIA have a architecture that relies on a CPU? Is that the question?
Or needs a CPU? Yeah, not relies on it necessarily. But is there a CPU in the normal, what's her chip, N100 or whatever the hell it is?
A100, H100, those guys, right? Is there?
H100, yeah, and they have a new generation on top of that.
Yeah.
I'm losing track of their model numbers, but does do the server farms that contain all of these NVIDIA chips have a CPU? Or is there an operating system? It probably is
Yeah. Got it.
distributed, but is there
Yep.
one machine that controls what's going on in all the rest of them? Or I don't know. I haven't. My brain has not gotten there yet.
Well, we will be getting there next week. Because that sounds really interesting. Do the suit?
With Fred, maybe Fred understands.
Yeah. So does the server farm have one CPU that controls all the other one, and how important is that? Uh, and then there's another question. There was a follow up question about, man, it's so crazy. It's such a weird world. It's so science, sci-fi. And then you got the data centers that are being built, and the people in the communities don't want the data centers being built. It's almost like the same things that happened with the unions in the
They want them, but they don't
1970s.
want them.
Yeah.
The
Can you
journal
talk?
just Wall Street Journal just did a story on how much uh, data centers are increasing the cost of energy in
Yeah.
the communities around them.
So, can you talk more about the reasons why TSMC got started? Did you ever do that investigation in the 1980s and 1990s? Because it all started because the unions, right? The unions in Silicon Valley didn't they wanted more
Nah,
pay.
nah. Uh, Again, it's multivariate, it's a bunch of different things going on. But a core thing is Morris Chang, founder of TSMC, who, yeah, he started out as like a Taiwanese manufacturer, and then he got more and more into making semiconductors and figured out the process and became the dude. He's actually not running the company anymore. I think he's like executive chairman, but he was the guy that figured it out, right? Probably in real time. And uh, so, um, so there's that, right? There's a company that is kind of catching all the stuff that's coming out of the U.S. and making it happen in Taiwan. Um, but in the U.S., because we had union, yeah, I mean, this is where the unions come in, but our workers were unionized, even though, still today it's only 12% of our workforce, but it's,
Mm-hmm.
the high
Well,
paying manufacturing jobs and similar. Um, the union's job was to increase the income of their members and to do that in negotiation with the companies. And so there's a series of mistakes that you can say, but these are only mistakes in hindsight, where the companies kind of gave in and said, okay, we'll work with you and we'll make sure your union members have a great life, mainly the UAW, because the car business was such a big piece of our manufacturing. We still have a lot of factories here in the US. And so that's not completely eviscerated. The problem is that they're not capable of producing at the same rate or cost as the China factories. So the American companies started moving manufacturing overseas and really to China. There is some in Vietnam, there is some in Korea, there's,
Mexico. Yeah. Yep.
here and there. And in part because they were competing with the Japanese companies, which
Yep.
were highly efficient and scaled. And so they were reacting to competition with China, Japan. And if you go back 40 years, there was this idea of Japan Inc.,
Yep.
which is that Japan was going to take over the world because they're so good at scaled manufacturing and they're so disciplined and consensus based. But even the Japanese didn't figure out what was going on in China. So they have had the same problem, now have the same problem we do. And then it became a race to become really good at manufacturing stuff in China. And Apple is the iconic company in that because they taught China how to do scaled manufacturing of
Crazy.
hard tech. And this is all in hindsight. We're sitting here now going, oh shit, wish we hadn't done that. You can't just turn it around. And this is where Trump is.
Doesn't understand technology. He doesn't understand technology.
No, but my feeling is he's actually doing all the right things,
but he doesn't know it
for the wrong reasons.
Yeah.
Because he's vindictive and mean and all these other things. But in fact, he's brought everybody up, and they're all going, "Oh crap, got to deal with this." And fucking Trump, but they are actually dealing with it. So it'll take 15 or 20 years, but we will become better at competing internationally. And because it's in our interest. But it's going to take a long time. It took China 20 years to figure it out. It's going to take us another 20 years to figure out the next level. And this robotics thing you're talking about is the sort of core issue. It's like, well, if robots are going to reduce the cost of manufacturing, China's got the best robots. Maybe.
Yeah. Well, man, because it feels like that thing we were talking about, the servo motor with harmonic drive reducer.
Yeah, I don't know what that is, but how big is that thing?
It's the size of a hand, it looks like.
Size of a hand. Pretty big, right? Because that, if it's going to be that big, it's got to go into something bigger, right? And a lot of what China's done is really tiny things.
Yeah, interesting. But they do it all. They do it all. They've got like all the components, all the entire foundation of every manufacturing. It's all done in China. Like there's nowhere else where that foundational layer is.
They make their own rare minerals.
They own the refining. They own the refining.
No, they own the actual in the ground.
Yeah,
they've got it in the ground.
Yeah,
right, and they haven't been bothered by environmental issues. So it's like sticky, but they don't care. They're just making it.
But they also refine it. They also refine it. And I read a great tweet the other day about the fact that they run on EVs is actually makes them not very good at airplanes, because airplanes require jet fuel, and jet fuel is a byproduct of car fuel manufacturing. And so the U.S. has a great system where we have airplanes and we have cars with combustibles. And China basically has railroads and EVs. And they're actually not systems that work. You can't have EV cars and airplanes. You need EV cars and railroads, because then they rely on the same similar structures. So they're two different things. And if the U.S. tries to go and build its whole EV structure, we have somewhat EV structure, then we'll lose out on the airplanes.
Well, we have some EV structure, but right now all of our batteries come from China.
Yep.
Exception in Tesla's mega factories. But
okay, wait. That reminds me of a tangent that I would love to go down on. There was a recent battery win that you guys had, right? Can you explain that Alsop Louis had with the battery production? Can you explain what happened with those batteries?
We have a company called Ion Storage Systems. I'm not sure when you're referring to, but this is part of our approach. We invest in really hard technologies because we think we know better and can figure out what will happen in the future. So this company, Ion Storage, is a startup company and doesn't really have any revenue. But QuantumScape and Solid Power are the two prior companies, both of which went public through SPACs and are still worth billions of dollars, even though they still haven't delivered a product. So there's been this race to replace lithium ion batteries, which is what's in everything right now, with a different technology. And ion does that technology, as does QuantumScape and Solid Power.
And does that rely on lithium?
There's a little bit of lithium, but it's not
the whole thing.
It's called solid state. They're still called lithium batteries, but a very small amount of lithium and not much of the rare earth stuff. Anyway, they come out with different processes, and Ion has a process that they invented and control and have a mode around that allows them to build solid state batteries differently than the other guys do. This has been speculative because they had to actually apply this process and start making them. And they are now making cells. Just one of the interesting things about Ion is when you look at what Meta's proposing for glasses with data on the screen, the fundamental requirement is, I'm not saying Meta's a customer of Ion, and they're not, but you have to make batteries that are really small and really dense. One of the things Ion can do is create a cell and then cut it into little pieces. Can't do that with QuantumScape and Solid Power. And so they can put a battery in an extremely thin thing that fits over your ear for a pair of glasses, and enable the maker of glasses to make glasses that look fashionable and still have all that stuff in them, just put them on the screen, and so you can look at data while you're wandering around. This is really obscure, but it's demonstrated significant interest in Ion to the point where we're beginning to think this company might actually become very valuable, even though it's worth a fraction of the public companies.
The win that I was referring to was the Wall Street Journal did a piece on it that says a battery that lasts 50% longer is finally in production. Solid state batteries have long been elusive, but a firm that supplies cells to the Defense Department could be first to get into them into consumer electronics.
Yeah, that was the win. It worked on that for over a year, bringing that reporter into the factory. Took me a year to write the article, but that's the way it is when you're in startups. So now, once they've written the article, it's a reference point for everybody else. But having the Wall Street Journal write an article is just right on the surface. What I'm talking about is what's going on underneath the surface.
Brilliant. So that's an interesting point. So we got about 10 minutes left. So we could talk about solid state batteries, or we could go back to TSMC because there's still a lot of questions I have about how that happened in the 1980s or the 1990s. What are you more excited about?
Batteries would be worth another session.
Okay, we should do a separate talk on the batteries. So TSMC, we had unions in the States. We moved it over to Taiwan. Did you ever write articles about that? Did you ever get close to those guys who were doing the Taiwanese stuff?
No, I had no idea. I went to Taipei several times, and as far as I was concerned, there's a whole bunch of Taiwanese manufacturers, some of which made computers, some of which made components, some of which made accessories. They're really good at manufacturing. They're the first ones to figure that out. Cheap, low-cost manufacturing, but they didn't have any sense of brands or, it was really hard to assess the difference between one and another. There's a company called ASUS, which is a Taiwanese company. I think it's still, but they started out by building clones of the IBM, and they were very cheap, and so it's a little bit, you get into Dell and all that kind of stuff. But so the times I went to Taipei, and I can't remember, maybe 2 or 3 times, I couldn't tell. I was like introduced to people, and I'd meet them and talk to them, and never introduced to TSMC.
So what is a fab? Why? Because TSMC is a fab, right? That's what they do.
Mm-hmm.
What is a fab?
To actually make the things. actually build the chips.
And they work with
So
the
they use
Silicon Valley
ASML
companies.
machines to do
Yeah.
they use ASML to do the lithography. They're probably the biggest customer for ASML. Um, and actually make the chips. These are all people in bunny suits and clean factories that are completely air controlled, and you know, which Intel
So,
and other people can do, but they had just massively scaled this.
so in those bunny suits, that used to be like when you showed up to Silicon Valley, did you go to a lot of factories where they were in the bunny suits, or was that already shipped off by that time?
No, it was being done there, but I don't think I ever visited. Or, I went to Intel and I talked to Intel a lot, but not in the factory.
You never went to factory.
So
That's the
I just
crazy.
thought, as from my point of view, starting out as an English major and being a trade journalist in the computer industry, I had to learn a lot to even be able to talk to people.
Yeah.
So um, I had to learn and understand. It was a lot of fun to do this, actually, given that nobody expected, including myself, that I'd be able to figure it out. Um, I had to learn how chips are designed, how
Yeah.
they're made,
Yeah.
but it's not my specialty. And, there were other people who really focused on
Yeah.
and understood semiconductors. I mean, Ben Thompson at Stratechery, who come later,
Yeah.
he seems to understand this stuff, and he actually lived in Taiwan
Yeah.
until 2 months ago. I think he moved back to the U.S. Um, and so he probably did tour TSMC and get to know the people there. And it's just not, I had to know enough that I could communicate with people that knew more than I did,
What was
which I
your
did.
specialty?
But
What was your
hmm,
specialty? What was your specialty in the 1980s? It was
software.
yeah, software. Got it. Yep. Yeah.
And in the 1980s, while I was writing my newsletter, I went to an executive session at Intel to talk to them about software. Though at Intel in the 1980s, they did chips, memory chips, processor chips, and they did hardware. There was actually nobody in the executive team that actually understood what happened to those chips after they were sold to their customers. And that was software, and software was built on top of those chips. And um, so they actually asked me to come talk to them about software. And I was like, felt like I was way over my head because I didn't actually understand what they knew. So I was talking about software without understanding what they knew. And um, I never got invited back. So I don't know if that's good or bad. That was when only the paranoid survived. What's his name?
Yeah, I know who you're talking about.
The guy who came out of World War II.
Yeah, the
God
Hungarian guy.
almighty.
Yeah, Hungarian
Yeah.
guy.
Uh,
Yeah, look it
I knew
up.
another one, and I keep thinking of his name, but anyway, I won't try to
Uh,
do that.
so very
But he wrote a
interesting.
book called Only the Paranoid Survive, um, which is ironic because, of course, once he was not CEO and he ended up passing away,
They love.
um, they forgot the lesson.
So it's a really interesting point about software and hardware because now, man, it's like there's so many avenues of investigation to understand technology, and software itself is giant. I understand it a lot better now that I can vibe code software, but I'm so interested in vibe coding hardware, and I know it'll happen eventually, but it's probably far away.
Now, there's some family you mentioned at the Arduino, or what's the other one?
Yeah,
Um,
ESP30, Arduino, Raspberry Pi. These I've got my first
one
Raspberry
of those
Pi
things.
in Buenos Aires. Well, it's my second Raspberry Pi, but the first one didn't work. I've got my Raspberry Pi down here, and I'm going to start programming on the Raspberry Pi once I can turn the software on. I couldn't turn the software on the first time.
Yeah, but vibe coding and hardware would be the ability to plug together different components and then program.
What do you
So
mean?
this is about, I'm sure I've said this, my very first experience in 1979 was being at Inc. in Boston and hearing about this personal computer stuff. And the company there was the company that invented the spreadsheet, Software Arts. And they built it for the Apple II. And so I'm going like, this is what everybody's talking about, using a spreadsheet on the Apple II. was this phenomenon that was happening in business, and Inc. was a magazine for business. And so I ran around talking to people and going, okay, there's a computer, right? I get that. And the computer has hardware in it, and then it has software in it. So how do you tell the difference? And I go around and talk, every 12 people I talk to, 6 of them would have a different answer than the other 6. So it's like, I'm sitting there going, even these people don't know how to describe this.
Yeah.
So I figured out I had to figure that out. And the layers between just the raw hardware, the bare bones hardware, and the applications you're using are multiple layers in between. There's firmware embedded in the hardware. There's tools to write programs, and there's the operating system to manage the whole system, and then there ultimately there are applications. And like, what's the difference between a programming environment and an application?
Yeah.
Not much,
Okay.
but there is.
Yeah.
So I had, and that was part of why it was so much fun. Is that this was like a whole area that I had no clue about, but I had to learn in order to operate in the industry.
Well, and it's still the same way because, oh man, there's so many questions I want to ask you, but we're going to end in the next few minutes. But you said something interesting about the vibe coding and the components that feels really important for me in my next step. What did you mean by vibe coding components? What do you think I should focus on in turn? Now that I got my Raspberry Pi here, what should I focus on building?
Well, Raspberry Pi is a computer, right? So you can program it. I don't know if you can program it by vibe coding yet.
Yes, I can. I know how I can. Yeah.
Right, but in order to have a thing that's going to do what you want it to do, you probably have to have other pieces, right? Not just the computer.
Yeah.
The input output. How does it communicate with the outside world? I don't know what a Raspberry Pi has on it. I think it's got memory and a CPU.
Everything you just talked about has it in there. I can install Claude Code. I've already installed Claude Code on my Linux server. And I'm now used to a Linux server. So I've now got Claude Code on my DigitalOcean, so I can vibe code on my remote server. So I know I can do the same thing on my Raspberry Pi. So I can get Claude Code on that Raspberry Pi, and all the input, output, all that stuff I think comes baked in. I know that it has Bluetooth and Wi-Fi, so I know I can connect a remote. I can get into it via my computer, my physical computer, and then components. So I think I can just attach those things. But there's all these layers of the fact that it is a piece of hardware. There's embedded systems. Last 2-3 minutes, what is an embedded system and why is it important?
Generally speaking, an embedded system is software that is embedded in hardware.
Oh.
And there's a variety of ways to do that, but it basically means sort of conceptually that when you make the hardware, you put the software in the hardware and you can't change it. Updating firmware is very difficult. Embedded systems are kind of firmware. That's changed, but back in the day, embedded systems were manufactured in the chip once the chip was manufactured. So you couldn't change it once it was there. So you have an operating system around it, and the operating system would deal with issues that created. But that was kind of conceptually true. Now I got to say, after 50 years of doing this, I've begun to lose a lot of the details here.
The details aren't that important. It's more like what I'm getting from you is actually the implicit knowledge and the sort of like understanding of what's it for. Now I understand what an embedded system is in terms of the basic understanding of just like, oh, it's a thing that has firmware and the firmware is hard to do, and that I can kind of abstractly think about it now.
It's yeah.
The
problem is, this is what I learned. This is the whole theme of our little continuing conversation here. So I learned this stuff 50 years ago and kept up with it pretty well for the next 20, 30 years. But once I became a VC, I wasn't as embedded myself in the system. And so I rely on other people to kind of tell me. And the other people in my case is Gilman Louie, my partner at Alsop Louie, who, we decided to invest in a company, which has since been bought, that had a process for building chips using copper, that
Hmm.
allowed you to stack chips. That's where I learned about stacking chips. Because when you get down to 2 nanometers and very small devices, you can't go sideways. You got to go up. Got to stack the chips. And then there's a system for communicating between the stacks. Anyway, I mean, so I learned that. I figured that out in order to understand what we were investing in.
Yeah.
And But it's a little random whether I figured something out or not.
Well, it's normal. Well, thank you so much. I'll let you go to whatever you have going, but it'll be a good one next week.